right, what's up? So today we're on a podcast, Mosaic Podcast episode number 12. So Julien, right?
Yes, Julien. Yeah,
okay.
Julien.
So
Yeah.
Julien, have you heard of like Fermi Paradox?
Yes, I do. Yes.
So how do you think about that? Like if we are the only species, in this universe, it would be fucking creepy. If there is, like higher intelligence out there, like, beyond human being, that will be super creepy too. Right.
I agree. And you have few theories on to explain indeed why is there this big silence in space, which is indeed, from a statistic point of view, it would make more sense to hear other people because the universe is so big, and then you would have of course some you would expect that there are other sentient beings out there. So why are you not hearing them? And there are a lot of theories, and most of the people say that maybe they are too far, and that indeed to receive some kind of messages from someone, then you need to have someone send a message in the right direction with the correct power, and you need to have someone also listening in the exact same moment, same direction.
How do we make sure we're sending the signal in the right direction?
Exactly, and that's the whole point. That's why it's so difficult, and I think that's why maybe we think it's silent, but maybe we're not listening at the right moment, right direction. And for instance, when you consider the SETI program, which is
it's like the search. Oh no.
Yeah, that's a program from US which is trying to listen. Search for extraterrestrial intelligence. Exactly, and they have very few means, very few antenna, and they are only listening to some parts of the sky, very few moments. So maybe indeed by just keeping listening, you might still get a message. But I think one of the other difficulties, like, what do you expect in terms of message? It's not going to be hello. It's not going to be something you are able to understand.
They could be living in the fourth dimension, right? Which, the message doesn't make any sense in the
exactly.
In the three dimensions.
Exactly. Maybe actually what we are receiving and considering as noise is actually a real message. And if you look also at what the messages that we have been sending as well, because we have been listening, but we have been sending messages, whether that's inside the Voyager's satellite, you had some kind of weird pictures and things, and also like what people are trying to send to trigger other intelligence. It's not easy to try to just put yourself in the situation of an alien, and then to what would they understand from my message? How can they decode it?
So have we received any signal so far, message from
there are some
universe?
unexplained messages, but most of the time they were always explained by science after a while, like it was some quasar stars or pulsars, or but so far nothing. And I wish we would indeed receive something, but you have also this theory that if everybody is keeping quiet, it's because you might have some predatory aliens which are killing everybody who's saying hello. So actually you have
you have to be quiet.
Yeah, some people say that if you start shouting, then you're actually triggering the attention of aliens which might not be pacific. And that there might be some kind of alien form which is targeting specifically planets which are kind of shouting, like we are now sending radio frequencies. We are shouting. But to be able to listen to the Earth, you still need to be within a certain distance. Because we are shouting, but the further you go, the fainter it gets. But still, so some people believe that to send messages to other to other people out there, it's maybe actually risky, and it would actually jeopardize the whole humanity, because if you have superior life form, and you're telling them, "Hey, I'm there." And exactly, and they have no intention to, maybe they are going to come here, Independence Day style, like to kill everybody, take your resources. I mean, some people say, please keep quiet.
But do you believe that theory, that the ancestors of human being are actually aliens?
No, I don't believe
and Earth as an experimental planet to grow this specific species.
No, well, first of all, I don't believe in kind of a big plan. That life on Earth is part of a big plan. So first, I don't really believe in that. But even if some people say that some bricks of life were brought onto Earth by some asteroids. So you have some kind of bricks of proteins, which might have been brought on Earth by asteroids. And I don't really believe that there is this kind of that life is coming from somewhere else, or that we are part of an experiment. But I do believe we are not alone. I mean, it's
so. I heard one interesting theory, which is, I watched that from YouTube actually. Mars actually, you can't really live on Mars right now because the lack of atmosphere and radiation, all kinds of things. But Earth had that situation before, long time ago. It was very similar to Mars.
Well, I think
so the theory was, actually there were a bunch of the super intelligence actually been to Earth. And, the Elon kind of super intelligence to the Earth and built what we are right now, right? The human being and humanity. And they just go extinct, or they just kind of left the Earth and
Well, I think first I think it's more like Mars was more similar to Earth earlier. So they kind of had the same, I would say, use. But Mars is a bit smaller, so it was a bit more difficult for Mars to keep its atmosphere. So most of the atmosphere went away, which is why Mars is like this now. But they could indeed prove that some water, liquid water, was on Mars before. And actually, another planet is Venus also, which had also a use which was quite similar, but then it became it's really hot, very thick atmosphere on Venus, and some people, it has a huge global warming. Global. I would say Earth could look like Venus if we don't do anything, in very long time. So that's where you see that also Earth has such a unique situation that between Venus, Earth, and Mars, only few parameters were different in terms of distance compared to the Sun, or compared to in terms of size, etc. And that's where you realize that if you change just a little parameters, then you end up with having completely different
environment
and
conditions.
Exactly.
It's pretty cool. So, recently we have seen, major breakthrough. Elon to send 2 astronauts to ISS, and they returned successfully just last week, a few days ago. How do you think about, because space tech was mostly owned by the government, right before, like NASA or any space agency, ESA, and in Russia as well. But now we're seeing a big trend that it is going to be privatized, like SpaceX, like OneWeb, like you, right? Yes. You're working on space technology as well. So, what is the most, what do you see is most profitable in this market the next 10 to 15 years, because there's actually less than 10% of the whole market shares is actually on in the space, and most of the market is actually on the ground stations and ground satellite. So what is your perspective like, for the next 10, 15 years? Is there any new business model coming out from the space industry? Because I actually saw someone like trying to build the space hotel. Basically, it's a
indeed
completely crazy idea from Starburst, the Techstars accelerator. So how do you think?
Well, I think there is indeed a market for what is coming next is space tourism. When you see how much was paid for, I think Denis Tito, who was a billionaire, to just like spend 1 week on the ISS.
Yeah.
There is definitely a market for this, and then you have first suborbital flight, like we call it. So it's going to be like Virgin Galactic. It's going to be planes which are going to go into space but then directly come back. So you are not going to do completely a round of the Earth, but you're going to go to space, see how it looks like from space, experience gravity. So it's a bit more like I would say entertainment park, where you I mean, of course they're a bit more expensive, but first when I say expensive, it's like they say they want to sell the ticket something like 100,000 euro or USD, sorry, which is expensive for probably you and me. But for these people and for I would say a lot of people, it's not that much expensive. So there is definitely a market for that. And as usual, the more people will go, the more the cheaper it will get. And then the more affordable it will be for everybody. So then you start to have indeed this kind of price
cost down.
Cost down, exactly. So that's I think the next part, the next thing coming. Then of course you have the moon. Instead of having a scientific base in Antarctica, then I think the next place would be the moon. For a science purpose, it's very interesting because you can start to do science experiments you cannot do on Earth, especially as you have the moon acting as a shield. If you are on the dark side of the moon, I would say, and you are protected by the moon, you can listen to certain frequencies you are not able to listen from Earth because you have some noise, like your smartphone. Everything is making noise.
Yeah.
So if you have this kind of shield, then you can look at space and already in certain frequency, in certain bands that are not possible from us. So from a scientific point of view, it really makes sense. And of course, it would be the first base to expand in the solar system and to really go further. So that's why I know a lot of people want to go directly to Mars, but I think Moon would be first. And I think it would serve as a lot of tests for really understanding if the human body can sustain space, because it's definitely not a kind of environment. And as long as I know how much people want indeed like to travel to space and think it's just taking a plane, but it's really much harsher environment.
Is there other way to travel to space? Like, I've heard of one super crazy idea is to build like the largest elevator and it goes up directly to space. And there's one Japanese corporate that's actually working on that. But the problem is the material itself, because it has to be lightweight and has to be very cheap. So basically, they would build so there's certain, like we have low Earth orbit, right? But it goes up a little bit to a place where it orbit the same speed as the Earth spins.
Geosynchronous orbit, yes.
Okay.
Which is really, really far. It's like we are talking about something like 36,000 kilometers.
Yeah.
And low Earth orbit, space, the limit, it's 100 kilometers. Okay. So when you are indeed in geosynchronous orbit, it's 36,000 kilometers. So you can imagine how huge and the material you need to resist that. It's going to be super stiff. But
so there's one crazy idea. But do you really think like Elon's idea to travel to Mars with Starship, which he had built the prototype recently? Do you think that makes sense in the next decade?
It makes sense as long as you don't really expect, I think, a flight back to Earth.
It's a one-way ticket.
It's a one-way ticket, but I mean, like I think you have a lot of people willing to do that. I mean, like when you just imagine like the first settlers of US, they just left everything. They went to US and they didn't expect anything. They just wanted, like the new frontier. And even the first settlers, they were not even attracted by the riches or by gold or by anything. When they arrived, it was New England, which was not super famous for like any specific resources compared to South America, where maybe indeed the gold of the Aztec or the Maya was maybe a bit more attractive to the Spanish. But for the English people at that time, I leave everything. I just take a boat for a few months, and then I arrive.
But you can take a boat back.
But most of them never did. And I think of course you need to from a psychological point of view, it always helps to know that you can come back, even if you are never going to come back. I think it helps to know that you have the possibility to do so. And I think part of the plan of Elon Musk is indeed to allow for this. But I think to be sustainable, I think most of the people have to go there and never come back, and really like try to have this effort of settling, of terraforming if possible, even if some people are really doubting it's ever possible.
I was thinking like how is I know Elon's plan is to send cargo by 2022 and to send the first batch of crew and cargo by 2024 and eventually 1 million people to the Mars by 2050. But I just wondering like how do you land the first batch of crew on Mars? It's not like you have people on Earth to land on the sea. How is it going to work out?
That will be the job of the first settlers, to really have indeed a better launch pad and better support infrastructure for the next ones. So indeed the first missions are going to be maybe the roughest one, probably done by professional astronauts or people really trained for it. But the more people you will go, you will send there, the easier it will get for the next ones.
So how about for regular people? Like, let's go back to space travel, right? Mm-hmm. Because we are not astronauts, and we haven't been through all kinds of training, like zero G-force, like all that kind of like tough training. We don't have to go through training to take a plane, but we have to at least take, I don't know how long will it take, like several months off to go through NASA training just to take a ride to ISS or to the space. Like every single thing you have to exercise like every day, like at least 2 hours, inside the ISS. How is that going to work though?
No, indeed, there are indeed some problems from a physiological point of view. Indeed, that the longer you stay in space, the harder it is with the radiations, and the more muscle you lose, the more your bones are also losing part of their resistance. You had a lot of experiments done on the ISS, and indeed space is not kind on the human body. So that's one thing, and indeed when you are talking about a trip to Mars, it's more than 1 year. It's 18 months if you take the shortest route.
I thought 6 months.
Sorry?
I thought 6 months.
Mars. But 6 months. But then you would have on the way back. It would be. The whole trip would be 3 years.
The whole trip would be.
Yeah, if you would come back, it's 3 years in space, because Mars is not. The atmosphere of Mars is not protecting you either. So you need to have indeed some shieldings everywhere and on the shuttle, on the base, everywhere, because otherwise indeed like the radiation are going to completely destroy your body. So that's one thing. But then indeed you have the psychological effects. having people living together for a full mission, it's really, really, really hard. And I think some scientists say that might be the barrier, actually, that it's not going to be a technological one, but it's going to be a limitation of human beings to stay in a very closed environment with the same people for so long. And they did some experiments on Earth. I think one was Mars one, and they had to stop some of them before the end of the experiment because people were getting crazy inside.
And you will likely get cancer, like 5% higher chances of.
I think still the physiological one could be overcome. I mean, if you believe indeed that with Darwinism, and indeed, like the more you will send human into space, and if they would start to reproduce in space, then obviously there would be a natural selection of the best ones, which are able to survive such harsh environments. But that would take a lot of time. That would take a lot of people who are going to indeed have a disease, have some issues. So that's
so I'm not really a physics guy, but I know that like with huge gravity force would actually slow the time down, right? So does that happen like within our solar system, like,
yes.
Mars and Earth, because we know Mars is like 1/3 of just Earth, right?
Well,
so time-wise,
there is some relativity effect that you can even measure from between a satellite and the ground. But it's something you will not notice as a person, because it's such a tiny difference that only scientific instruments can measure with atomic clocks. Yeah. So you can already measure it between from a satellite, and indeed the Einstein relativity was tested and confirmed in a satellite around the Earth. So of course there are some relativity effect, but I think the most difficult thing when you think about time between Mars and Earth, it's definitely the time communications can take between the two planets, especially if you are completely at the opposite of the orbit compared to the sun. Like you're talking about between hours and days of it's more hours, sorry, between the moment you send a message and you get a response. And if indeed something happened on Mars and you have an emergency, and then if you look at I think everybody has seen the Martian movies.
Yeah.
And indeed how hard it is.
Interstellar. Have you guys watched?
I love this movie as well.
Man, I've watched like several times. Like that moment when he has gone back to the spacecraft and he realized that his daughter is actually grown up, and man.
In the solar system, you would not experience something like that. But
I think
you would still have a feeling of how huge the solar system is, and indeed that communication. So that it's actually light, speed of light. It's taking like a few hours, and that indeed in case of problems that you have to wait. When you look
how long would that take to send, like, let's say if I'm on Mars and I want to like send a WhatsApp text back to Earth, like how long would that take?
Well, it's considering that you would
by laser or like
if you would, let's say if you send it by laser and you would aim at Earth first, it would depend what the configuration of Mars and Earth around the sun, because they could be very close, which is indeed when we talk about a trip of 6 months to Mars, it's considering that they are in the configuration where they are at the closest, but when they are completely opposite from the sun.
Let's say the closest.
Yeah.
How much time would that take?
That would take a few minutes, but it's few hours.
That's pretty long. That's pretty long.
But I think then you need, of course, to have the capability to send this directly. But usually you have a satellite which is orbiting Mars, and it needs indeed to be just right at the right moment when you want to send your message. So that's why actually the hero from The Martian, it's not just few minutes. It's sometimes he has to wait for complete hours because the satellite has to be in the proper configuration, and then it's a bit more complicated than that. But it's already like few minutes to few hours depending.
Yeah, I actually got tons of questions to ask, Julien is so insightful. So, but, I left 10 minutes, but let's go back to your company, Odysseus.
Odysseus, basically.
Odysseus. Mm-hmm. So, can you tell us a little bit about, you are like one of the very few people here in Taiwan, start up, a space tech company, and all the other guy. It's only like not more than 3, I think, here in Taiwan. So, when did that all begin? Like, how did you start this company by doing tech transfer in Chengkou Daxue, Tainan? How did that work out?
Well, to go back at the beginning, I think people noticed by now my French accent. So I'm from France, and I studied over there, and I started to work for a company called Easy Space in the Netherlands. And they were.
You co-founded that, right?
No, I didn't. I was just an employee over there. So it was co-founded by some Dutch people, and. So at that time, the new space and the nano satellite, like we call them now, the CubeSats, it was really emerging. So it was really going from kind of university projects. Only few people in the world were doing this kind of very tiny satellites, and these guys in the Netherlands, they were one of the first company to decide to do that as a job, as a company, to really build satellites for other people, not just as a university for yourself. And so I started to work for this company, and during this job, I had the opportunity to work again with my best friend, Jordan, who was in Taiwan in Chengkou Daxue, and he was project manager of the CubeSat of this university. So Chengkou Daxue in Tainan, they were one of the first universities in the world to actually do CubeSats and nanosatellites. So that was actually very, very nice for Taiwan.
CubeSat is like one of the categories, right?
Yeah, so it's nanosatellite.
We have ground satellite.
Nanosatellite is usually, the definition is a satellite under 10 kilograms. CubeSats.
So when you launch CubeSat, you would launch several CubeSats at once, or?
It's usually several CubeSats at once.
Okay.
Depends. Of course you can send only one. You had already rockets only sending one CubeSat, but most of them carry between 10 to 50. But I remember the first missions we were doing with Easy Space in the Netherlands. It was only maybe 4 to 5 CubeSats at once. Now I think they broke the record again to launch 150 at the same time. So that's where you see the market completely expanded, and it went really crazy because now it's a lot of universities, even private companies doing this kind of satellites.
So where do you specialize? Satellites do satellite communication, or you build the CubeSat, or you build the subsystem?
At first, what was interesting is that you could test for very cheap in space some kind of experiment, because for a lot of universities it was a bit frustrating because they didn't have any access to space. They had to collaborate with the space agency on a 15 years project, billions of US dollars project.
Where does most of the space agency come from? Is it from Japan, US, or Europe, or?
Oh well, it was of course it was coming from the US. But even for American universities, very few were able to collaborate with NASA. And so for a lot of them, actually, they started to, why not try to fly our own little thing? And it started like that. They were using components from phones, from laptops, putting them together and just fly it. And of course, the first ones, it was roughly a Sputnik, like just making beep beep, and everybody was happy because they could receive it. But then it became more and more complicated, and people were including more and more high-end technologies, like for attitude control, for communication, and some guys started to realize, actually you can do something. There are some applications very useful you can do from that, and some people started to put a camera, and they realize that for the cost of a huge satellite, you could send hundreds of them. So instead of having one picture, maybe very good quality, but only one picture every few days of one point of Earth, you could get daily images, maybe 2-3 times per day. And then they understood that, at least for Earth observation, that's what you call spatial resolution. So the resolution of your picture, it is important, but it's not one of the only important things. It's also how regularly you can update this picture, how often you can see the changes. And that's as important as the resolution. It's can you detect changes? Can you indeed see how everything is evolving? And now you have indeed companies using small satellites which are scanning the Earth on a daily basis. And then it's opening new applications, because you can already, for instance, use it for finance or economical purpose, because you can detect economical activities on the parking lots in US during the COVID, for instance. It was used it's used during the COVID crisis. It has to be
super high resolution, right?
No, not really, because you have some algorithms which are, I would say, cleaning a bit the images. But if you just see some blurry, gray things on a parking lot, of course it's going to be cars. I mean, you don't need to know the brand, you don't need to know the model, you just need to know it's a car. And just by having I would say a gray square, it's enough. So it's really depending on the application. For some application you need indeed very high resolution, but for some you just need to understand what's there. And of course, with artificial intelligence and with all this, I would say, learning algorithm, the more you feed your algorithm with this kind of pictures, the more they understand indeed what they are seeing. So the more it can be automated, and the more they can digest a huge amount of data. So
that is what Odysseus is.
No, so that's not what we are doing, but that's what you are seeing with smaller satellites, which are not, I would say, super high resolution, super high end, but I would say the strength is in the numbers. So we, as Odysseus Space, so we come from these people. We come from what you call the new space, and that's also why.
What does new space mean? You know, I heard
new space. It's a mix
space 4.0, 3.0. I heard new space.
It's a mix of miniaturization. So that's definitely the nanosatellite CubeSat world, where all the advances in miniaturization of laptop and phones, they are using it. So CubeSats, it's nothing more than flying laptops in space. A bit more complicated, but it's flying laptops. So that's one thing. The second thing is more standardization, so that you have more cooperation and people agreeing on how it should be all standardized, because before every country was a bit doing what they wanted. And of course, the third one is the involvement of private industry in much more areas than before. They are not just supplying and manufacturing, they are actually the people leading and having the real applications. And that's where you see Elon Musk. So before rocket, it was indeed considered as something sensitive or complicated, and only countries were able to do it. But now we have private companies who are doing rocket, and he wants to go to Mars. Well, he can go to Mars, you know. So there is nobody telling you what is possible or not, and now it's up indeed to people to decide what business model makes sense, and if they want to send a car in orbit, well, they can send a car in orbit, you know.
That's there. Yeah. So last thing, you know, space is obviously, it is so tough to run space company, right? Because you need so much fun to get things launched and things like that, and you would rely quite heavily on government projects or with space agencies here in Taiwan or in Europe. So I know it has been always tough for you to work with government because in commercial space we want everything to be super quick and super efficient, but the government has their own agenda. They are not moving quick now sometimes. So so is there any message you want to bring it out to the government via the podcast here?
Yeah, sure. First, I would maybe I don't think I explained a bit in details what I'm doing, but we are doing R&D on technologies for indeed this small satellite market. Yeah. So we have a project of developing, for instance, optical communications. So we are not doing satellites. We are doing some parts of satellites which we think are going to be disruptive for the market. Okay, so this said, when we arrived in Taiwan, it was for a very good reason. I mean, of course, it was opportunity based because one of the co-founders and my best friend Jordan was project manager for the nanosatellite in Chengda, Changkong-Dashi, and. So we thought, it's actually a very good place to do small satellites because we have access to all the big guys who are doing laptops and phones, and it would make sense to have access to these people. But what we came to realize, it's like when you do R&D, it's always a partnership between a company and some public institutions who have the facilities to do R&D, especially when you are talking about space. There is that much you can do with few people in an open space or in a garage, I would say. At some point, you need to have access to people with facilities. So that's why we wanted to cooperate with universities in Taiwan and our public institutions or the Taiwanese Space Agency. So even if we have a very good relationship with NCKU, and they were very helping with us, and we had small contracts here and there to really start to do R&D as a cooperation framework where you have a public institution helping a company. It's difficult. In Taiwan, it seems to me that universities and private companies are living in kind of different bubbles. Each with their own funding source, but there is no real cooperation. Actually, very few young people after they graduate do internship in companies. Most of the time they do their master or their PhD within the lab of the university, but they don't really interact with private company. And I think first it's not that great for the students because, well, after you go to the university, the first thing you want to do is to get a job most of the time in a private company. So to have already this kind of experience of what you should expect in the end after your study, I think it's great for students. And at the same time, as a private company, a lot of people say, well, students is cheap labor and interns. Well, yeah, that's one thing, but I think it's also a nice opportunity for a company to test a student as a potential employee for later on. So if you see the internship is great and that the collaboration is going very well, then me as an entrepreneur, well, I want to hire these people. I want to have the opportunity to keep them, to keep them working on my project. So I think it's really a win-win situation where the more collaboration you have between universities and private companies, and the better it gets for everybody. And that's, I think, something which is lacking in Taiwan.
Cool. All right, thank you very much. So I think we pretty much covered everything. I hope that I can invite you next time because we haven't gone deep into space travel and time, space time, those kind of interesting things. All right, thank you very much.
You're welcome. Thank you. Bye bye.